Hey, how's it going? My name is Heassler with Cruz Gonzalez. I'm studying Petrochemical Process Engineer in the UAT Reynosa Aztlan, and I'm going to talk about methanol. So let's begin. Definition: methanol, also known as a methyl alcohol among others, is a chemical with the formula CH3OH, a methyl group linked to a hydroxyl group, often abbreviated MEOH. Methanol acquired the name wood alcohol because it once produced chiefly by the destructive distillation of wood. Today, methanol is mainly produced in distillation by hydrogenation of carbon monoxide. Introduction: methanol is the simplest alcohol consisting of a methyl group linked to a hydroxyl group. It is light, volatile, colorless, flammable liquid with a distinctive odor similar to the ethanol, that is drinking alcohol. Methanol is, however, far more toxic than ethanol. At room temperature, it is a polar liquid with more than 20 million tons produced annually. It is used as a precursor to the commodity chemicals including formaldehyde, acetic acid, methyl terbutyl ether, as well as a host of more specialized chemicals. Production: from synthesis gas, carbon monoxide and hydrogen react over catalyst to produce methanol. Today, the most widely used catalyst is a mixture of copper and zinc oxides, supported on alumina as first used by ICI in 1966. At 5 to 10 MPa and 250 Celsius, the reaction is characterized by high selectivity. Carbon monoxide plus 2 molecules of hydrogen will have methanol. The production of synthesis gas from methane produces 3 moles of hydrogen for every mole of carbon monoxide, whereas the synthesis consumes only 2 moles of hydrogen gas per mole of carbon monoxide. One way of dealing with the excess of hydrogen is to inject carbon dioxide into the methanol synthesis reactor, where it too react to form methanol according to the equation. Carbon dioxide plus 3 molecules of hydrogen will have methanol and water. In terms of mechanism, the process occurs via initial conversion of CO into CO2, which is then hydrogenated. Carbon dioxide plus 3 molecules of hydrogen will have methanol and water, but the water byproduct is recycled via the water-gas shift reaction. Carbon monoxide plus water we have carbon dioxide and hydrogen. This gives an overall reaction which is the same are listed in above. Carbon monoxide plus 2 molecules of hydrogen will have methanol. So now we have natural gas and steam and air. The natural gas goes to the sulfuration and the air goes to the air separator, so we can have oxygen. The 3 of them goes to the steam reforming, and the product goes to the compressor. Then the compressor goes all the way to the synthesizing tower, and we have crude methanol. Crude methanol goes into the fractionator, and then we have methanol. Biosynthesis: the catalytic conversion of methane to methanol is affected by enzymes including methane monoxygenases. These enzymes are mixed function oxygenases, i.e., oxygenation is coupled with the production of water. Both iron and copper dependent enzymes have been characterized. Intense but largely fruitless efforts have been undertaken to emulate this reactivity. Methanol is more easily oxidized than is the feedstock methane, so the reactions tend not to be selective. Quality specifications and analysis. Methanol is available commercially in various purity grades. Commercial methanol is generally classified according to the ASTM purity grades A and AA. Methanol for chemical use normally corresponds to the grade AA in addition to water. Typical impurities include acetone and ethanol, which are very difficult to separate by distillation. UV-vis spectroscopy is a convenient method for detecting aromatic impurities. Water content can be determined by the Carl-Fisher titration. So now we have uses and application of methanol. We have the heavy chemicals from formaldehyde, acetic acid, methyl terbutyl ether. Methanol is primarily converted to the formaldehyde, which is widely used in many areas, especially polymers. The conversion entails oxidation, as we can see in the pictures. Methanol to hydrocarbons, olefins, and gasoline. Condensation of methanol to produce hydrocarbons and even aromatic systems is the basis of several technologies related to the gas and liquids. These include methanol to hydrocarbons, methanol to gasoline, and methanol to olefins, and methanol to propylene. These conversions are catalyzed by zeolites as heterogeneous catalysis. The MTG process was once commercialized at Motunnui in New Zealand. Gasoline additive. The European Fuel Quality Directive allows up to 3% of methanol with an equal amount of gasoline to be blended with gasoline sold in Europe. China uses more than 1 billion gallons of methanol per year as a transportation fuel in low-level blends for conventional vehicles and high-level blends in vehicles designed for methanol fuels. Complexes that produce methanol in Mexico. Independencia Complex. Currently, Petróleos Mexicanos has 8 petrochemical complexes, which only the Independencia Petrochemical Complex located in the Mexico-Puebla Federal Highway belonging to the municipality of San Martin is the only national producer of methanol. Total production of methanol in Mexico. So we can see in the graphic, we have 1,000 tons reached every year from 2001 to 2012. So we reached to the final, and that'll be it, and thank you for your time.